Today, we talk about the new Insta360 X6 camera. This is the new 360-degree camera and the iLock mode that it supports. What is this iLock about? And what does it mean for editing our videos? How does it improve the video quality? Well, very soon we're going to find out. I bought a X6 camera. It's going to be delivered to me soon. And we're going to experiment with it and see whether it really improves the image quality. Uh, so this lock feature is available in Insta360 X5, the current model that I'm using. But the lock profile is only supported at lower resolutions. So normally we record at 5K, 8K, okay, 8K resolution, but it only works for 5.7K, not 8K. So that means we lose resolution when we use the lock profile, right? Um, uh, well, fortunately, it's we don't have such a restriction for the X6 camera. X6 camera will work for any 360-degree mode, regardless of the resolution. So it will support 8K resolution in 360 degree mode with the iLock 10-bit. Also, it's it's a bit different from the older format. Um, the old X5 Insta360 camera only supports 8-bit iLock, whereas X6 now supports 10-bit iLock. So there are more bits for color. Okay, let me explain what this lock thing's about. But firstly, let's take a look at why we need better color. Let me show you a clip that I shot using my Insta360 X5 camera, the old camera, for a hike that we did at Maju Forest. And let me show you how bad it looks. So this is the video that I edited and I posted to Instagram. Okay, this is the Instagram reel. Let me open with a QuickTime Player. So the beginning of the video looks okay. Everything looks nice and green and all that. But as we go into the video, it looks quite bad. It looks like a very dull, muddy, dark kind of mess. This is not good because one of my purpose of using this camera is to do archival video footage. We are going to walk through Maju Forest, right, which might not be around in a few years' time. We want to capture it as faithfully as possible. But trouble is that the colors are not quite right. So the green and the brown are kind of mashed up together. It gets worse because this is not being shot in bright sunlight. Notice that if it's dark, the colors are all muddled, right? If it's brighter, it tends to work better. So I was thinking, what could we do to improve this video? That's why I decided to buy the Insta360 X6 camera and check it out. Well, the other improvement for the Insta360 is that it supports 50 frames per second. This was shot at 30 frames per second. So when we jump it up to 50 frames per second, hopefully it will increase the quality by a lot because you're capturing more pixels. The larger sensors in the Insta360 X6 will also help. They will capture more light, so hopefully it'll be less dark. But the other thing that really fascinates me about the Insta360 X6 is that it supports log format. And log format is supposed to capture more colors more faithfully. So hopefully we won't get this kind of a muddy mess between green and brown, right? You'll be able to do some color adjustment to make it stand out. So what is this log format? Why is it called log? Is it log like a tree log? Not quite. So if we look at the definition of log profile, a log profile is something that's supported on digital video cameras. And log doesn't stand for tree log. It actually means something else. It's the mathematical definition of log. It's a logarithmic profile, as in logarithms. When you say that a equals 10 10 to the power of b, uh, then b is equal to log 10 of a. That that logarithm. So it's a logarithm versus exponent, right? You might have heard of some of this log profile before because on Apple cameras, iPhones, they call it the Apple log. So you can now record Apple log videos on the iPhone Pro cameras, not on the regular iPhones, but iPhone Pro. And each camera has its own format. So Sony has S log, for example. DJI drones, they have their own D log. So each one of them is slightly different. They have slightly different formulas for computing your log. Okay. So I'll go to that. I'll go through that in a while. What's so special about iLog? So iLog, okay, that is mentioned here, is the Instagram log format. Apple, remember, iPhone has its Apple log and Sony has a log. Well, now Insta360 cameras have their own iLog. So iLog is just log profile, but specific to Insta360 cameras. What does it look like for a log profile? How is it different from normal videos? Well, here's an example. Normally, a video will look like this, nice contrast and all that, very rich colors. Um, but you can tweak the Insta360 camera to shoot it in a log format like this. Notice that everything is all very washed out, poor contrast, and the color saturation is all gone. But realistically, this is the better image. So there's a problem between this image and what we see in our eyes. Our eyes will prefer nice uh, images like this with proper contrast, proper color saturation, and all that. But however, this is not ideal for manipulation, for editing by a computer. The reason is this. This video has a lot of this video here has a lot of detail, right? But as we try to adjust the contrast too much, and adjust the color too much, we lose a lot of information, right? If we the original image in log format has got a lot more detail that gets lost when the camera converts it into a visible format that our eyes prefer. Yeah. In short, things are not what they seem. Our eyes prefer this kind of image, but computers actually prefer this kind of image because they will store more information. Yeah. So the advantage of doing this is that as our Insta360 X6 camera records in log format like this, it will capture all the detailed colors, all the all the details in the sky, all the details in the sand, and all that, without losing any information in there. Which means that if we bring this Insta360 X6 camera on our forest hike, it will capture the greens and the browns in very accurate colors. And then we can edit it and transform it into this format, right? Yes, there is some loss of information where we convert from this image into this image. Yeah. But that's because that's what our eyes prefer. Our eyes prefer to have a nicely contrast image with the proper kind of saturation, right? But ideally, this is the best representation. It has all the information that we want, from very dark shadows to very light sources, very bright light sources, and all the colors are in there. This is sufficient. This has plenty of information that is sufficient to generate this image that our eyes prefer. Let's talk a bit about the log profile and why it looks so washed out. Now, okay, so this is the log format. To understand how the log profile works, we look at the documentation for Insta360 X6. If we do some searching for Insta360 log format, they call it iLog, remember? iLog is the Instagram Insta360 brand of log profile. LUT is a lookup table. It's a lookup table that will allow us to translate this original image captured by our camera into this image that our eyes prefer. We'll see the internals of a LUT, a lookup table in a while. Yeah, there you go. Now, if we go out to this Insta360 iLog format, so you can see that there is an iLog for X6 and X. In fact, only two cameras supported, X6 and Lunar Ultra. There are older ones like X5, but these are 8-bit iLog. So it's a great improvement that Insta360 X6 now supports 10-bit iLog, and 10-bit upgraded from 8-bit is a huge improvement. This means there are a lot more colors that are supported. Okay, in a while I'll download this X6 and show you what exactly is inside an LUT, a lookup table. But first, let's look into this link here, the Lunar Ultra. At the bottom, there's something called 10-bit iLog white paper, and we download this. When we click download, you will see this. Okay, so this is interesting. This will tell us a bit more about what's inside the Insta360 iLog format, the log profile for Insta360 X6 cameras. Now, it also helps us understand what exactly is this log formula got to do with it. Why mathematical logarithms are involved in this log profile. Yeah, so the idea is that we want to do a logarithmic gamma curve. So the gamma curve affects, the brightness or the darkness of color. It transforms everything using the mathematical log function. Why are we doing that? Because we want to have a wide dynamic range, meaning that we can represent the very dark, shadowy colors all the way to the brightest colors. Imagine not just white, but a glowing white color. Let's say you are filming a glowing white LED light bulb. Well, it will help you to represent that, right? So that's why this will preserve highlights, like glowing light sources, as well as shadows. Like we're hiking through the mud, we see a lot of shadows, a lot of dark browns and all that. We want to distinguish between them, so that we can know that this is a shadow and this is mud. It's gonna look different. Okay, the transfer function is going to be okay. I don't quite understand what's going on here. I'm not sure why it looks this funny curve. This is not a logarithm curve. But anyway, but you can see that we have 10 bits of value to be used. So it's 0 to 1, 0, 2, 3, right? It's not a lot of bits. Some of the bits below are unused. I believe they're actually reserved for special functions. We'll talk more about that in a while. Yeah. What's important is the next part. So it tells you that there is a function here that allows us to convert screen reflectance and digital code values. First, let's talk about scene reflectance. What does that mean? So scene reflectance is like when we talk about real world objects, right? Real world objects, when it's captured by a video camera like Insta360, it captures a reflection of that real world object. If the object is dark, it will not reflect any light, correct? That's why your scene reflection will be 0 degrees, 0%, sorry. Scene reflection could be 100%. When it's 100%, it means that let's say it's a pure white object that is reflecting pure white light, and it's reflecting 100% of the light. So it's a very bright white object, and that will give you 100%. But this is something interesting. Scene reflection can actually go up to 2,200%. That's above 100% of scene reflectance. What the heck does 2,200% mean? Well, we are now going beyond scene reflectance. We are going towards light emission. Like I said, if you're looking at a white color object that is reflecting white light, yes, the most you can go up to is 100%. But what about a white light bulb, like an LED light bulb that is emitting white color? Well, turns out you can actually go quite bright. In this case, for this particular camera by Insta360, they will allow you to go up to 2,200%, compared to 100% reflectance. So this is a very bright light source. It's actually emitting light color. and this camera will be able to represent that number. So the trick is this: we want to be able to do all these numbers. So 0% means total blackness, but we also want to represent normal reflection, the 18% up to 100%. For a normal object that reflects color, that reflects light. But also we want to cater for very bright light sources. Let's say, if you're pointing the camera at the sun, for example, there's a limit to how much brightness you can capture, but at least you can capture up to 2200%. And remember that we only have 10 bits of value, for your red, green, and blue. Well, how bright can we go? We could go from 0 to 1023, because 10 bits will give 1024, right? To the power of 10. However, I believe it doesn't use 92 and below. 092 could be some reserve values. I think we could look at our specs and confirm that. But we want to make sure that the brightest, the brightest value, the brightest color that we can represent, 220, 2200%, can be represented in 10 bits. And this is why we assign the largest value, 1023, to this super bright, color, emission of light. Yeah, so we can see that it's not really a linear computation. You talk about 0 to 2200, and you talk about these values here. It can't be linear, because if this were linear, let's say if it's a straight line function, then you will see that, yes, we can assign this number, 2200, to the very largest number that we can represent, 1023. But then you realize that there's a lot of gaps in here, right? 220, then there are numbers like 2100, then 1900, and so on and so forth. There's a huge gap from these two values. We do not want a huge gap between these two, because we're wasting a lot of values, right? That's why it makes sense to use a logarithmic scale. Sometimes when you plot a chart, then you realize that the numbers are kind of all spaced out. But the same information, the same problem here. From 0 to 80% to 2200 is actually a lot of numbers. But we only got this limited space to represent it. In the real world, when we draw this kind of chart, we will use a logarithmic scale. For things that grow very fast, that grow at exponential scale, we will want to use an exponential logarithmic scale to plot these graphs, so that it still appears as a straight line, a normal sloping line, except that the scale goes exponentially. And that's why we're able to capture so much different variations in light, from dark to simple reflection to light emission, with just 10 bits of values. And it's quite remarkable, right? And that brings us to a log function. So we can see that the computation is like this. So Insta360 has helpfully given us the precise function that's being used to compute this. How do we convert 2200 into 1023? Well, the formula is here. And notice that it uses the logarithmic function. So it's log base 10. It could have been log something else, but I think for convenience, they use log base 10, right? So if we look at, if we take 2200, we could plug in the value here. I believe it's in the input value. Yeah. There are some other constants that we'll come to in a while. But the point is that we're taking this huge value, 2200. We are taking the log 10 of that value, okay, with some adjustment, and that is the output. Output will give us 1023. So that's why we're able to represent huge jumps in value, even though it's only 10 bits. That's because we are using the logarithm here to represent large numbers, large gaps in the values. All right. Now, if you want to go into details, the constants are defined here. So there's there's alpha, which is this. Then there's a beta here. This I believe is delta. Delta is here. Then there's a nu, I guess. Then you have a nu here, and you have a phi, which is here. So lots of interesting parameters, and there's a tau even. So there's some kind of a lower threshold. If the input value is less than some lower threshold, it will use a linear kind of thing. So this is a straight slope, right? But for most values, it will, if it's beyond a straight slope, it will use this log 10. Yeah. So for very dark values, it will use a straight slope. This is near to darkness, near to total darkness. But for very bright values like sunlight, we will use log 10. Okay. Now, something special about the log 10 function. Why do we need to adjust it by this? See, notice that it's adding the input value plus theta. Theta is, yeah, sorry, theta not 5. Theta is 0.01. The reason for this is that the log function is a bit quirky. If you look at the logarithmic function, regardless of whether it's log 10, log e, or log 2, it log of anything or the value 1 is actually 0 because, you know, 2 to the power of 0 is 1. 10 to the power of 0 is also 1. So it kind of crosses here into the 1. Then it gets into negative territory, which is going to be very strange for our function. We do not want to experience negative numbers. Yeah, so that means because log base 10 of 1 is 0, right? But log base 10 of 0.1 becomes -1 because 10 to the power -1, right? So that's why values below 1 will get negative. And that's why it gets complicated. So I believe that's why it uses an addition function here. So we can see that it's at the plus theta. Theta is 0.01. It kind of shifts the value a bit so that we don't go into negative values because negative values don't make much sense on here. And maybe that's the reason why theta is quite close to tau. You can see the lower limit is tau, which is 0.01, but it just happens also that the log 10 is shifted by 0.01. So maybe it's trying to compensate for that strange minus value. Yeah. This function here is a reverse, right? So to convert this number into here, we do a log 10. And then to convert the number back from here to here, we do a 10 to the power of something. So it's just the inverse of this function. It's doing backwards, right? Yeah, so this is the proof. So now we've seen that exactly why it's called a log format. It's called a log format because we are doing a conversion of the gamma values, okay, into a 10-bit code value by using the logarithmic function. And the reason for using a logarithmic function is that it will compress a lot of this huge gaps between numbers efficiently into 10 bits. Between 18% and 2,200%, there's a lot of numbers, but yet we are able to represent it correctly in 10-bit values. Also, from 0 to 18%, there are also 50 shades of gray. Lots of different shades of gray color. The log function is also good for doing this kind of well, not so compression but expansion. So it's able to represent slight variations in the darker values as well. And that's why we have, that's the reason for using a log format. We're using a log profile for a lot of video cameras because this is the log profile, right? This is the original image that our eyes prefer, but this is the log profile that cameras and computers prefer because this one actually has a lot more information. It shows a bit washed out because it's reserving the large values for very bright sources of light. If we are showing the sun here, for example, it will be able to see the sun in different shades of brightness. And then even for dark places, like if you look at this corner here, there is a black and there is gray, right? But then when we convert to this eye-friendly format, everything is all black, right? So a logarithmic function is very good at preserving this kind of subtle grayness. It knows the difference between very, very dark black and different shades of gray, 50 shades of gray, right? And that's why we use the log profile. And log profile is going to be very exciting because it means that our Insta360 X6 camera will be able to represent videos that have this kind of precision, this kind of color precision from the very bright colors to the very dark shadows and different shades of shadows, right? All right. There's something else interesting in this format. So in this white paper by Insta360. Okay, so okay, I'm not going to pretend I know this about the white points and the different colors, but the point is that we use RGB to convert. So there's a There's a red, green, and blue component. So each one of them has its own value, right? So the logarithmic gamma value will correspond to both red, green, and blue. There will be 3 values. Now, something interesting here is that it talks about the ITUR BT 2020. Okay, now what exactly is an ITUR BT 2020? If you Google it, you will see this. Okay, firstly, all this funny recommendation, all these funny, terminologies. Firstly, when they say REC 2020, it doesn't mean recording or recorded. It actually means recommendation, right? Recommendation BT 2020. Most people will call it REC 2020. You hear it a lot in YouTube videos. What is BT? If you download the recommendation, the spec, BT stands for broadcasting service. And what is this ITUR? Okay, this is a long story. So ITUR is the International Telecommunication Union. If you think about how our phones work, how people communicate over the airwaves, and how people transmit information, that is controlled by the standards body known as the International Telecommunication Union, ITU. Now, then what is ITUR? ITUR is the radio communication sector. Radio communication sector of ITU will define the specifications for radio communication. So what the heck is ITU 2020, ITUR 2020 under the radio communication sector? Well, it's because these are specs defined for HDTV. Remember that HDTV, high definition TV, is a TV video broadcast format that works over the air. Our TV stations nowadays will broadcast TV programs over the air in HDTV formats. When you broadcast this information over the air, you need to tell it how to encode colors. That's why there's going to be a BT 709 for older formats. And just now we saw a newer format, which is BT 2020, which is a newer format, right? Yeah, so that's why BT stands for Broadcasting Service for Television. It's meant to define how high definition TV programs are broadcast over the air, precisely how we encode the colors inside a high definition TV broadcast, right? So it sounds very complicated, but yeah, today we're talking about the BT 2020 standard that is defined by the International Telecommunication Union, specifically the radio communication sector. Yeah. And BT 2020 is meant for broadcasting of HDTV. Okay. So that's it's a complicated story there, but this is BT 2020. Now, you hear about BT 2020 because we saw it in a white paper, but actually, a lot of us don't quite use BT 2020 yet. We are still using the older standard. The older standard is called REC 709. Also BT 709. This is the older standard. Why why are we using REC 709 and why are we not using BT 2020, REC 2020? Well, the reason is this. REC 2020 is still fairly new. It supports larger formats like 4K, which is quite new, right? I mean, HDTV started with 720p, 1080p, but now we're going into 4K and 8K. So that's why you need a new standard. The REC 2020 standard supports that. Then today we're talking about color representation, right? That's why the color standard matters. If you look at this very helpful chart here, you can see that REC BT 2020, the new one, which is supported by Insta360, can represent a lot more colors compared to REC 709. So 709 has only got this limited range of colors, but REC 2020 can go all the way up to more colors. This means that it's possible that there are some monitors that do not support REC 2020 because they can only show this number of colors. I'm thinking maybe, there's maybe some very bright colors, maybe some very bright white colors that cannot be represented by Rec 2020. Sorry, cannot be represented by older monitors in Rec 709, and you need better monitors in Rec 2020. Yeah. So that's why for most of us people, we are still stuck with the older standard, which is Rec 709. Yeah. In fact, you might ask, as we create videos for Instagram, Reels, for YouTube and all that, which standard should we use, Rec 2020 or Rec 709? Well, this is what most people say. We should use Rec 709, the older standard, right? Because it looks okay on phone, tablets, and computer screen, right? We should not use Rec 2020. Sometimes you see videos on Instagram that have got a high dynamic range. There's like some videos look to be very bright. It looks as though the screen is glowing. That's because they're encoded in high dynamic range and they use Rec 2020. So the problem is that then Instagram has a problem. It will change some of our colors. It may try to, make things that are very bright into less bright, and maybe it'll turn very dark shades of gray into black. So therefore, it will look bad, right? It will look over bright or desaturated, right? Instagram fault. That's what they do. They do not support Rec 2020 faithfully. They will try to do some manipulation and it will look bad. Yeah. So therefore, like for example, they even mentioned here, like if we use Apple Log, which is logarithmic format profile on iPhones, they recommend that you can record in Rec 2020, but you need to convert Rec 2020 into Rec 709. But remember that the color space is different. There are some colors in Rec 2020 that cannot be represented in Rec 709. Like these colors here, this space. If your color falls into this space here, there's no way it's going to be represented in Rec 709. So therefore, you need to map it down, like downscale it to something that can be represented in this yellow rectangle here, triangle here, in Rec 709 format, right? Yeah, so that's Rec 709 versus Rec 2020. So yes, Insta360 X6 is ready to support BT 2020, which has got a lot of colors in there. But most of us are not ready for that. Instagram is not ready for that. Instagram only works with BT 709. Therefore, when we try to edit our videos, in Premiere Pro or Final Cut Pro, we should target BT 709, not the BT 2020, because we're still using older standard that has got fewer colors, right? Maybe someday Instagram will support BT 2020, but for now, we prefer to manage the colors ourselves. We do not want Instagram to convert, our colors, our Rec 2020 colors into strange colors while it converts into Rec 709. Yeah. So therefore, we will now edit our videos in Rec 709 format, even though our camera supports Rec 2020. Now, so okay, how do we start editing our videos in Rec 709 format? This is where we need an LUT, a lookup table, right? Lookup table basically it converts this function here into a series of numbers that we can easily look up and convert, from one value to the other. I can't recall whether it's converting from this number into this number or this number to that number. I believe it's this number to that number. Okay, but I might be wrong. Why do we use a lookup table? Well, different cameras have different formulas. So we don't want to program our video editing programs, all possible formulas. Maybe some Insta360 will use log 10. Maybe somebody else will use log 2. Somebody else will use log E and all kinds of different log functions. Maybe some won't even use a log function. They use some exotic function to compress the numbers. Therefore, the best way to do this is that every single camera will provide its own LUT, a lookup table that will convert the numbers from here to here. Yeah, so let's look up the numbers for Insta360. We're back to the Insta360 download page. There is a if you search for Insta360 iLog, we will see the lookup tables here. If we click download, okay, it will download the LUTs, okay, lookup table. If you go inside, you can see a whole bunch of LUTs. So this is quite interesting. What do they mean? Now we've seen the so this is Insta360 X6 log format. They call it iLog format, right? Because it's Insta360 branded. We saw the Rec 709 and Rec 2020. Okay. We hear that Instagram Reels does not support Rec 2020. So therefore we can ignore all these. We will not be using Rec 2020. We'll just use Rec 709. Now there are two versions of Rec 709. There is a S33 and S65. What exactly are they? S63, 65 basically tells us the resolution. Okay, let's hit on to here. Now, as we convert into the lookup table, right? We need to push in values for the the reflectance, and we need to convert it into a 10 big number. Therefore, we need to do some kind of lookup against a grid. Now, the grid is going to be either 33 by 33 by 33 or 65 by 65 by 65. Why? That's because we have RGB values, red, green, and blue. That's why there are 3 dimensions of this lookup table. It's not just a simple 1-dimensional lookup table, it's a 3-dimensional lookup table. But so now we're talking about the resolution of the lookup table. How many values are there in the lookup table? If we have more values in the lookup table, it's more accurate, right? It will we can get values more precisely. We will prefer normally a 65 by 65 by 65 versus 33 by 33 by 33 because S65, which is what it's called, has got more grid values. It allows us to do the lookup more accurately, right? S33, which is 33 by 33 by 33, has got fewer grid values, which is less accurate, but it's good because it's faster lookup. Yeah. Therefore, for most video editing, we want better quality video, with better and more accurate color conversion, which is why S65 is better, right? Only problem is that S65 is heavier on resources. When we use it in Final Cut Pro, in Premiere Pro, it will be slightly slower. But then our computers are quite fast nowadays anyway, so maybe it's not so relevant today. So really, we should use S65 because it has got more values. The lookup is more accurate, right? And therefore, we will use this one, Rec 709 S65. This is the lookup table that we should use. What exactly is inside this .cube file? Well, I open it in a text editor. This is what you see. It's actually a text file. So it tells you that it's iLog to Rec 709, 3D size 65. This is the number of lines. If you look at that, okay, it's more than 65. I'm not sure what 65 means, but these are all the values. You see RGB values, right? If you trying to understand what these values are, I did a search. So each row has an RGB output values. Okay, so it's 0 to 1, right? So therefore, the idea is that we pass an input. The input is an RGB value. The output, yeah, and we need to multiply by 63 and round it to the nearest integer and so on. Yeah, so that's how we do a lookup for a 3D a lookup table, right? We need to pass in the RGB values. Then the row number is equal to R times 64 times 64 plus G times 64 plus B. This will give us the row number, right? So this example here, we take this RGB value, and this will convert into RGB index, which becomes an index. So, and this becomes a row number. 25427. Therefore, if we want to convert this RGB value, 0.1, 0.2, 0.3, we need to go into row 25827. So, I mean, it could be something like 25427, right? So I could just go to um, Control G, go to 25427. Yeah. So it's the offset is probably a bit off, but around here, right? So this will give us the RGB values that we need to do the conversion correctly, right? That's why this .cube file is a lookup table. It's a three-dimensional lookup table for RGB, and internally that's how it's represented. Now, trouble is that what about values in between? There are some values in between. So we are only handling 64 steps of red, green, and blue, right? That's why we call it the S64 65. Okay, S65 format. There are only 65 values for red, 65 values for um, green, and 65 values for blue. What about something in between? Can we have like 1.5, 1.8, or 1.9? That's where we have interpolation. So that's why it says that in reality, we will need to do some interpolation. If we have something values in between the whole numbers, we can use trilinear or tetrahedral interpolation. Yeah. So this will actually do some kind of it's a 3D space, right? So that's why it's a trilinear or tetrahedral. It's a 3D kind of interpolation, not just a linear single line interpolation. Yeah. So we look up 8 to 4 surrounding elements, and then we will use that to average out the output value, right? So the file format looks deceptively simple. It's just 64 times 64 times 64, but actually it's possible to interpolate these values to do something more accurate. Yeah. Okay, so so let me wrap up this discussion here. We don't have the actual Insta360 X6 camera. It's going to be coming soon. We don't have any video yet to do the experimentation. But I hope to do it in the next video. Right. We have the .cube file. This is a .cube file that we saw. This is the iLog to Rec 709. And it's the X65. Oh, 65 is the loop size. Okay, that means it's 64 by 64 by 64. The dimensions of the cube. How do we use this file, this .cube file? Well, this is the file that we can load into Final Cut Pro. Final Cut Pro will allow us to load in this file, and then it will magically transform our video from, from this dull gray format into this vibrant bright format that our eyes can see. But then realistically, we will do some kind of color grading, color correction. Sometimes we need this to be a bit brighter. Sometimes we need this a bit darker. Like for example, for the Maju Forest video, we might need our video to be a bit, to highlight more of the dark shadows, the darker areas. So we want to push it down to make more of the dark areas visible, not so much the highlights. We don't have much sun in the forest, so showing adjusting our colors to look brighter, to accommodate the sun will not be helpful. Instead, we need to adjust our colors to accommodate the shadows. Yeah, as we saw here, there are variations in the shadow colors here. There are different shades of gray, but everything gets crushed into black here, which is not good. Therefore, we need to do some additional color adjustment to bring out the shadows, and we can see different shades of gray. And whether it's a dark brown kind of gray or whether it's a dark green kind of gray, we need to distinguish that, whether it's vegetation or whether it's mud. Right? That's why we will need some additional color correction beyond that. Yeah. That's what we'll do in the next video. We'll try doing some color adjustments, color grading in our video. We will take our Insta360 camera recorded in iLog format, which is the Insta360 version of the log profile. And then we will put it into Final Cut Pro, load in the .cube file to convert it into a human visible, a human, pleasurable kind of view that we can do further tweaking, whether we need to brighten the image or darken the image. And one last thing is that to enable this, we need to switch the camera settings. We need to go into this thing called um, color mode must be iLock 10-bit. Yeah, because by default it will support the the typical color lock. Yeah, and the typical color lock will give us, this kind of image. But this is not what we want because everything is all crushed, all the shadows are all gone. We need to switch the camera to say color mode is iLock 10-bit. This will allow us to capture the video in this format, which has a lot more color detail, which we can then tweak it in our Final Cut Pro to adjust the colors accordingly and make it look better. Yeah, so stay tuned for our next video in which I'll try to do the actual iLock mode and the actual lookup table, the .cube file. I'll leave a link to the video in the description. Thank you. Bye.